So this is Dr. Scott with the Business Department, here with some homework help for week 3 in BUS110 Business Math. So hopefully everything that we've done so far has been a refresher. As we progress through the weeks, we will actually start using this math, so it'll become it'll make more sense. So I transferred everything over to Excel because, well, I like to use Excel to do math versus a calculator, especially during this type of presentation. So your assignment this week is to do the even numbered problems, and I don't want to do your homework for you. So I'm going to do the odd number problems and talk through them with you. So numbers 1 through 7 ask us to identify the place value. And as you may remember in your book, when we look at the place value, everything, we view the decimal as the middle. So everything to the right of the decimal would be 10, 100, 1,000, 10,000. And then to the left of the decimal, which you're probably more familiar with, you would have your ones place, tens place, and if you had 100, it would be hundreds place. So when we talk about the place value, we're talking about what number that represents, how many ones, for instance, we have 7 ones. How many tenths do you have? We have 5 tenths. How many hundredths? We've got 3 hundredths. How many twos? We have, or how many thousands? We have 2 thousands. And how many 10,000s? We have 8. And a really good way to remember this is for every 0 the number would have, that's how many decimal places you have. So 10,000 has 4 zeros. So we know that the 8 represents the 10,000 place. So let's start doing these. So our answer is, we have to identify the place value. We have 7 ones, 5 tenths, 3 hundredths, 2 thousandths, and 8 10,000ths. And we haven't really done any math yet. We're just talking about the numbers. So 0.7391. We have 0 ones, so we don't have to talk about them. We have 7 tenths, 3 hundredths, 9 thousandths, and 1 10,000th. So 5.8312, we have 5 ones, 8 tenths, 3 hundredths. I don't know why I keep trying to type thousandths. 1 thousandth. And 2 10,000ths. Our final one, we have 6 ones, 5 tenths, 5 hundredths, 5 thousandths, and 5 10,000ths. All right, now for this, we need to round to the nearest cent. And I will share with you that there are graduate students who have a really hard time with rounding. So what you want to do is you want to make sure that you're always starting off on the farthest right number, which is a 5. And when we round, anything that is 5 or over gets rounded to the next number in the spot to its immediate left. So 775, or 7, the 5 makes the 7 become an 8. And that's as many cents as we're going to go, because we know that even though this is a 7 and it would make this an 8, we're rounding to the nearest cent, which means that we're rounding to the nearest hundredth place. So that makes us 4822.775. And since I'm doing this in Excel, something interesting is going to happen. It's going to do it for me when I get away from the, see, 4822.78. So it double checked me. I was correct. Now, we're going to get back to talking about numbers, but now we're going to convert fractions to decimals. And 8 over 100 looks a lot like 8 divided by 100, because that's exactly what it is. So you could just do that in your calculator, but to do it in Excel, I just do this. And it is 0.08. Same thing. Oops. Excel, I have to say equal to let it know I want it to do some math. 0.061. Now, before we go on to these others, you may notice something. 100 has 2 zeros. So what we really did is we just moved the decimal place over from the numerator 2 places. So instead of 8, it becomes 0.08. And instead of, and 1,000 has 3 zeros. So once again, in 61, we pretend there's a decimal there, and we move it 1, 2, 3. So by that logic, 91 over 100, which is also 91 divided by 100, should be 0.91. So let's see if we're right. And we are. So this one in the book is actually 16 and 61 100ths, but for whatever reason, Excel just really, really wanted to solve this problem without me asking it to. So I put the plus sign in there. So again, if we know that there's 2 zeros, we're just going to move our decimal from the farthest point of 61. We're going to move it twice, 1 for each 0. So 1, 2, which will give us 16.61. Let's see if we're right. And we are. Okay. So now we're just going backwards. Instead of converting from fractions to decimals, we're just going to be converting 2 fractions. Please note that, oh, we didn't follow the directions. I just noticed that these directions say round to the 100th is needed, and we did not do that here. So to round to the 100th, because the second place to the right of the decimal is the 100 spot, 1 is less than 5, so we simply get rid of the 1. That's all we do. But now we'll convert these decimals to fractions, and we are not going to reduce them to the lowest terms. So 71, or 0.71, is 71 hundredths, which looks like 71 over 100. We have 125 thousandths here, because again, 1,000 has 3 zeros, which looks like 125 over 1000. Same thing for 0.825. We've gone to this thousandths place. So 825 over 1000. Now we have 0.065, which takes us into the 10,000th place. And that looks like 7065 over 10,000. And although many of these are divisible by 5, we're not going to reduce these to the lowest terms. The next one, we are to convert mixed numbers, but we are not going to reduce them to the lowest terms. So just like when we converted to the fractions, we know that we have 28 whole numbers, or 28 whole ones. We've got 8 ones and 2 tens, which is what 28 means. And then we'll have 48 over 100, because once again, there are 2 zeros in 100, so 1, 2, 48 over 100. Now, again, it reduced it to its lowest form, but you won't do that. So write the decimal equivalent, 5 thousandths. So the fraction equivalent of 5 thousandths is 5 over 1000. Now, based on what we know, since there are 3 zeros in 1,000, we need to move our decimal from its rightful place, from the whole number 5, to the right of the number, and we need to move it over 3 places. So that would be 1, 2, 3, which we should get 0.005. And let's see if we are correct. Nope, not that we're not correct. I just accidentally included some information that did not need to be there. 0.005. Okay, same thing, 85 10,000ths. So we have, that looks like 85, 1000, 0. So 10,000 has 4 zeros. The decimal on the 85, the imaginary decimal, is to the right of the 5, so we're going to move it 4 places. So we say 1, 2, 3, 4. So the answer should be 0.0085. And it is. Okay, so 33 asks us to rearrange the following and add. So we are going to arrange them such that we'll arrange them vertically. 0.4811. And then the next highest one is 10.8318. And then the next highest one is 4.7. And then the next highest one is 0.115. Now, you may notice that when we do things vertically, everything is justified to the right in this particular model. But remember, when you do this by hand, or if you were to do this by hand, you would line up the decimals. No, not what I meant to do. I meant to increase the decimals. And this one, more. And this one we just need to increase by 1. So now, and you don't have to add the zeros if you do this by hand, but I just wanted you to see that the decimals are all lined up. So we're going to add the 10,000ths, the thousandths, the hundredths, the tenths, the ones, the tens, and the 100ths. But we are going to let Excel do our math, just like you're going to let your calculator do your math. And our answer is 818.1279. So now that you've seen that, and if you need to rewind and watch it again, but I don't like a messy sheet, so I'm going to get rid of it. Rearrange the following and subtract. So there's not much to rearrange. We've got 9.2 and we have 5.8. Everything is lined up. So we are going to subtract the tenths from each other, and we're going to subtract the ones from each other. So we all remember how to add and subtract, so I'm not going to belabor this point. But it did. Not sure what happened here. I did the wrong thing. That's what happened. So 0.92 minus 5.8 equals, let's see if that's right. I think let's start on a different cell. That is also the tricky part of using Excel. So it only does what you tell it to do. And if you tell it to do something silly, it will do something silly. 9.2 minus 5.8 is 3.4. Because again, just like you do your, when you subtract whole numbers, if you don't have 2 minus 8, we have to make it 12 minus 8. And then that becomes 8 minus 3, or 8 minus 5 to get 3. So it looks like we're going to also have to do kind of the same thing here. We've got 3.4 minus 1.08. And if you are doing this according to, or if you're doing this the long way on paper, you now have 40 minus 8, which we know is 32, and you have 3 minus 1, which we know is 2. So let's come over here and make sure we're right. And yes, 2.32. Okay, so now our directions tell us to estimate by rounding all the way and multiply the following. Do not round the final answer. So we know that 3 is smaller than 5, so it just gets dropped off. We know that 1 is smaller than 5, so it will also get dropped off. We know that 4 is smaller than 5, so basically 0.04 would be about 0. And we know that 7 is greater than 5, so in the tens place, that becomes a 1. So what we're left with is 0 times 3.1. And when we multiply 0 by anything, we get 0. So this becomes, 5 is 5, so this becomes 8.83. 3 is smaller than 5, so this remains 0.8. Now, if we look at our other number, 4.9, we know that 9 is greater than 5, so we move it from the tenths place and make it a 1 in the ones place. So that leaves us with 5 times 0.81.8, which is 4. So now we have to divide the following and round them to the nearest hundredth. So again, it's just math, at least at first. So 29.432 divided by 0.0012. Okay, we've got this number, but we want to round to the nearest hundredth, which means that we're going to evaluate all of the numbers to the right of the hundredths place. So we know that 7 is greater than 5. So then this becomes a 7. 7 is greater than 5. So this becomes a 7. And once again, 7 is greater than 5. So we end up with 0.667 as our final result. So let's make sure we're right, and we'll take off the extra decimals. And we're right. Okay, the next one is very much the same way, just math. So where we're starting out, 7742.1 divided by 48. Now, once again, we do have 100 thousandths. We know this 5. We'll make this 7 and 8. This 8 will make this 3 a 4. 4 is less than 5 though, so we'll end up with 161.29. Make sure we're right. And we are. So next we have 2600 divided by 381. And we have a lot of zeros, a lot of here. So 2 is less than 5, so this 8 remains the same. This 8 is more than 5, so this 9 becomes a 10, which makes this 6 a 7. 7 is greater than 5, so it makes this 4 a 5. Again, 5 is equal to 5, so it makes this 1 a 2. 2 does not affect the 4. And 4 is less than 5, so it does not affect the 2. So our answer should be 6.82. And let's see if we're right. And we are. Okay, now in your book, this actually had the fraction, but every time I typed 1/25th, it told me it was January. Oh, or it did the math. So pretend this is a fraction, 1/25. So we're going to convert that to decimals. So 1/25 really means exactly what it looks like, which is 1/25th. We do want Excel to do the math this time, and it's 0.04. We don't have to round anything because the last place is the hundredths place. Same thing with 5/8. 5/8 is the same as 5 divided by 8. So we have 0.625. We have to round to the nearest hundredth, but we have something in the thousandths place. So this 5 makes this to a 3. Let's make sure we're right, and we are. Okay, now for this one, we are to complete the multiplications using the shortcut method. The shortcut method, I didn't really explain it earlier, but I alluded to it. There are 2 zeros in 100. So we know that to solve this problem, we simply need to move our decimal 2 places to the left, our imaginary decimal, because 2.5 or 258 is the same as 258.0. So now we need to take our, 258, we need to take our imaginary decimal point and we need to move it 2 places to the left. Right there. That is the answer. That's the shortcut method. If you want to test this, we can absolutely do that. 258 over 100, 2.58. Same thing. Okay, now we have 0.86 over 100. The decimal is already in the numerator. So now we just move it over 2 places. And since there's nothing here, we have to insert the zeros. So we have 0.86, which becomes 0.0086. Once again, if you're not completely convinced, let's do the math. But the whole point of this shortcut is to not do the math, but I just want to show you that the shortcut works. So for the last one, no, it's not the last one. For the next one, we have 48.6 times 10. We already have a decimal place here, so we know we just need to move it 1 to the left. So 48.6, we're moving our decimal 1 place to the left. Which means by the shortcut method, we got 4.86. And again, some of you are skeptical or not understanding it yet. I know, taught this class a couple times. So 48.6 divided by, or I'm sorry, times 10. And you know what? I thought this was divided by. So let's scrap that. When we multiply, we move the decimal to the right. So 1 0 and 10, decimal, moving it to the right. We start off with 48.6. We're going to take our decimal, take it away, and move it 1 place to the right so that it becomes 486. Now, once again, test it. 48.6 times 10, 486. Now, once again, since we're multiplying, we are moving our decimals to the right. When we divide, we move them to the left and make the number smaller. When we multiply, we move it to the right and make the number bigger. So now we have 3 zeros for times 39, or 3,950. So the imaginary decimal is right here. So we are going to put in 3 zeros. 1, 2, 3. Which brings us 3,950,000. We want to test that. 3,950 times 1,000. And it's correct. Same thing with this. 7.86 0.9132 times 1,000. So we take our decimal and we move it 3 places to the right because there are 3 zeros. 1, 2, 3. And if we still don't trust it and we want to double check it, 7.9132 times 1,000, and we get the same number. Okay, we're almost finished here. So word problems. Who doesn't love a good word problem? And I know that you're sitting here watching this thinking, no one loves a good word problem. But that's because word problems have a lot of words that are unnecessary. So the first thing you want to do when you encounter a word problem is figure out exactly what you need and what you don't. Doesn't matter what the person's name is. So let's strike through that. No one cares what Dustin's name is. So now we know that someone, doesn't matter who, got 7 hits out of 12 at bats. What was his batting average to the nearest thousandths place? Well, 7 over 12 is what we're looking at. 7 divided by 12 is the same as 7 over 12. Means that we're going to the nearest thousandths, so we need 3 zeros in 1,000. So we need to take it to the thousandths place. So we know 3 will not affect the 3 to the left of it, and this 3 will not affect this 3, and this 3 will not affect this 3, which is in the thousandths place. So again, we take it off. Put it on. 1, 2, 3, 4. His batting average is 0.583. Next, at the party store, Joanne Greenwood purchased 21.5 yards of ribbon. Each yard cost 91 cents. What was the total cost of the ribbon, round to the nearest cent? Again, we don't care where she was. We don't care who she is. We do need to know that she purchased something. So we've got someone purchased 21.5 yards of ribbon at 91 cents each. This one becomes pretty easy. 21.50, because that's how many yards she purchased, and the price of each yard is 91 cents, which 91 cents is literally 91 pennies, or 100 pennies in a dollar. So it's 0.91. And the answer is $19.56.5. We know that we're not going to be charged 0.5 cents, but that 5, since it is a 5 and not a 4, affects the cents in the hundredths place, and we will be charged $19.57. And let's, Cell says I'm correct. Okay, the stock of Intel has a high of 48.5 today, $48.50 today. It closed at $47.75. How much did the stock drop from its high? Okay, well, we don't need to know what kind of stock it was, so we'll take those words out. And so we have a high of 48.5. And it closed at 47.75. So it dropped by, what is the difference? How much did it drop? 48.50 minus 47.75. And it dropped 75 cents. So that's the homework. I hope this was helpful to you. If you have questions, please, you're welcome to reach out to me. Again, my name is Carolyn Scott. My email address is cscott@an.edu. You're also, if I'm not your instructor, please be sure to reach out to your instructor first and give him an opportunity to do his or her job. But otherwise, I hope you enjoyed this. I hope it made things more simple for you and less scary just to run through it. Again, if you need help, ask for it. Otherwise, I'll see you in another video. Have a great week.